Okay, so a kite is a shape that we're pretty familiar with from real life, but a kite in geometry has specific special properties. So a kite is a quadrilateral, which is a shape with 4 sides, that has exactly 2 pairs of consecutive congruent sides. This word consecutive means next to each other. So these 2 sides are consecutive, they meet at a vertex. These 2 sides are consecutive, they meet at a vertex. So they're right next to each other. Versus these 2 sides are opposite sides. They're across from each other. They are not consecutive. So if 2 sides meet at a vertex, they're consecutive. So a kite has exactly 2, so not less than 2, not more than 2, exactly 2 pairs of consecutive congruent sides. Here's a pair, the pair that's marked with 1 tick mark, that's our first pair, and then we have our second pair, the pair that's marked with 2 tick marks. So notice this side and this side, these are not congruent. This has 1 tick mark, this has 2 tick marks. So exactly 1 pair of consecutive congruent sides. So here's our main diagonal, but we also have a second diagonal. So in a kite, the diagonals are perpendicular, which means that they intersect to form right angles. So these 2, the main diagonal and the second diagonal, make right angles. So this is 90-degree angle, this is a 90-degree angle, this is a 90-degree angle, and this is a 90-degree angle. The diagonals in a kite are perpendicular. The second property is that one of the pairs of opposite angles are congruent. So 1 pair of opposite angles are congruent. So it's really important to know which pair. So it's the pair of angles that are formed by the 2 non-congruent sides. So this whole big angle is congruent to this whole big angle. So look for the 2 sides that are not congruent. They form an angle, and it's going to be congruent to this angle opposite it. So those are congruent angles. Then the third property is that this main diagonal, so the main diagonal, this purple diagonal, we'll say is our main diagonal. The main diagonal is going to bisect the opposite angles. So remember, bisect means it's going to split it into 2 congruent parts. So this main diagonal is cutting this top angle into 2 congruent angles. It's bisecting that top angle. And then it's also going to bisect this bottom angle. So these 2 angles are congruent to each other, hence why they're marked with 2 curvies. These 2 angles are going to be congruent to each other, hence why they're marked with 3 curvies. And these 2 angles are not congruent to each other because these are 2 curvies, these are 3 curvies, they're different. So they're congruent to each other, they're congruent to each other, but these 2 angles are different. They're not congruent. So a couple other things to notice. This is a triangle. What kind of triangle is it? It's an isosceles triangle, and if you remember, the isosceles triangle theorem said that if your 2 sides were congruent, then your 2 base angles are congruent. So this angle and this angle are going to be congruent to each other. This is also an isosceles triangle. It has 2 sides that are congruent. So if those sides are congruent, then the base angles are also congruent. So this angle and this angle are congruent. So a kite is created by 2 isosceles triangles stacked on top of each other. So if you notice, like this whole big orange angle, those are congruent. Then the top parts are congruent and the bottom parts are congruent. But this diagonal that's the pink diagonal, it's not the main diagonal. This pink diagonal is not bisecting these orange angles. So the purple diagonal is bisecting these angles and these angles, but this pink tongue twister. But this pink diagonal is not bisecting these orange angles. All right, so in this kite, we know that the measure of angle WXY WXY. So remember, the vertex is your middle letter. WXY. This whole angle up here is 104. WXY. This is 104. And VYZ is 49. In this kite, we're going to find the rest of the measures. So a couple things. We know right off the bat that in a kite, the diagonals are perpendicular. So I'm going to go ahead and make a right angle. Okay, then we learned that the opposite angles, those opposite angles, angle X and angle Z, those are going to be congruent. So this is also 104. So remember, you look for the two sides that are not congruent. They form an angle. Those angles are congruent. And then this main diagonal is going to bisect this angle up here. So if this is 49, this angle right here is also going to be 49. And then we can think about this little triangle right here. This is a right triangle, and we know one of its angles is 49 degrees. So I'm going to do 180 minus 90 minus 49 to get this angle right here. This little nugget angle is 41 degrees. 41 degrees, because 41 plus 49 plus 90 equals 180. So if this is 41 degrees and this whole angle is 104 degrees, I'm going to do 104 minus 41, and that's going to give me 63. So this bottom part, so this angle right here is going to be 63 degrees, because 63 plus 41 gives you 104. And then we also know that this is a right angle. So I have this right triangle right here, triangle XWV. And so I can do 180 minus 90 minus 63. And I get that this bottom angle is 27 degrees. And if this is 27 degrees, this main diagonal is bisecting this angle. So this is also going to be 27 degrees. And this is an isosceles triangle, so these sides are congruent, so these base angles are congruent, so this angle right here is also 63 degrees, which means that this angle up here is 41 degrees. Okay, so we want to find angle VZY. VZY is this angle right here, and it's 41 degrees. The measure of angle VXW. VXW is right here. It's this black angle. It's 63 degrees. VXW. Remember, your middle letter is the vertex. This is 63 degrees. And then finally, XWZ. XWZ is this a whole big angle. So I know that it's being bisected. Both of the halves are 27, so 27 plus 27 is 54. The whole enchilada is 54 degrees.